So for this section, it says, write a quadratic function in standard form that represents each area as a function of the width. Remember to define your variables. Okay, so for number 1, we have a builder is designing a rectangular parking lot. She has 300 feet of fencing to enclose the parking lot around 3 sides. So you want to enclose it around 3 sides. So let me just draw this 3-sided rectangle. Okay, it's only 3 sides. Do not close your box. This is a 3-sided rectangular parking lot, so we're only putting it around 3 sides. Now, how are we going to label this? So I'm going to show you which note boxes are going to help you with this one. So if you refer back to your notes, which I'm trying to click on, but it wasn't loading. Okay, so then you are enclosing 3 sides. This is box number 3. Do you see that? Enclosing 3 sides. So you would let x be the width, and then the perimeter would be length plus 2 of the width. And then the length is perimeter minus 2 width, and the area is length times width. Okay, so that sounds a little bit crazy, but let me show you what that means according to our example on the skills practice. So we let x be the width. That's this. Okay, and then the length, which is this side, I'll just put a question mark here. That's going to be 300 minus 2x. How do I know it's 300 minus 2x? Well, she has 300 feet of fencing, so that's where the 300 comes from. And then we're going to use up x twice. We're going to use up x on the top. We're going to use up x on the bottom. So you need to subtract both of those if you want to find out your question mark. So it's 300 minus 2x. And it says that in our notes boxes. So length is perimeter minus twice of the width. So that's the 300 minus the 2x. So that's kind of where that came from. I'm just trying to point it out to you. Okay. And then the area is going to be length times width. So we need to find the area function. So let me fill this in. Our width was x, and our length was 300 minus 2x. And then the area is going to be length times width. So area, I'll just write it as a parentheses x, so a of x is equal to x multiplied by 300 minus 2x. So you multiply it together because when you find the area of a rectangle, you just do length times width. So we have our length is the 300 minus 2x, and the width was x, so you just multiply it together. And then finally, we're going to distribute so that x gets multiplied to both of those. I'm going to write it over on the right side where I have space. So a of x is equal to x times 300 is 300x. And then x times negative 2x is negative 2x squared. I should have written smaller, but it's okay. So we got 300x minus 2x squared. And finally, if we want to put it in standard form, that means you want the x squared piece to come first. So we have a of x is equal to negative 2x squared plus 300. So you just kind of switch the order of those two. So this would be our final answer. I'll just put it in a box. So we started off with a rectangular parking lot where you have 300 feet of fencing to enclose the parking lot around 3 sides. So we drew our 3-sided rectangle. We labeled top and bottom x, and we solved for the 3rd side. Then to find the area, you just multiply length times width. So we got x multiplied by 300 minus 2x, and then you just simplify from there. Okay, I'm going to pause the video to see if you guys have questions. Okay, so number 3, because remember we're doing all the odd ones together. So scrolling down to number 3, Pedro is building a rectangular sandbox for the community park. The materials available limit the perimeter of the sandbox to at most 100 feet. Okay, so we're going to draw this rectangular sandbox. It doesn't say 3 sides, so that means you're going to draw all 4 sides of your rectangular sandbox. And let's label one of the sides x. just going to label the top part x. Okay, so since the top part is x and this is a rectangle, that means the bottom part must also be x. Okay, so now we have two of our sides labeled. We need to figure out this other side. So those two, the left and right sides, they are the same length, but we don't know what it is yet. What we do know is that the available material is 100 feet long. So you have enough to make 100 feet of perimeter. So you're going to take that 100 and you're going to subtract both of these sides. So that's 2 x's. So it's 100 minus 2x. And then 100 minus 2x would give you the length of both of these question marks together. However, we have 2 of these question marks, so we're going to divide by 2. I'm going to pause here and see if you guys have any questions. Okay, so a question was, how do we get it to be divided by 2? So let's first talk about the 100 minus 2x. The 100 minus 2x would give you the total of this blue sides added together, right? Because the whole entire perimeter is 100, and you took away the top and the bottom, the x and the x. So it's 100 minus 2x. So the leftover, 100 minus 2x, is the blue parts. However, there are 2 blue parts total, and you want to find out the length of one of them, so you must divide by 2. That's why it says divide by 2, because there's 2 blue parts, so you got to divide it by 2. Let's simplify 100 minus 2x divided by 2, because that is simplifiable. So 100 minus 2x divided by 2, you can simplify that by doing 100 divided by 2. 100 divided by 2 is 50. And then we have the minus symbol, and then we have 2x divided by 2. That's just x. So each of those blue sides is going to be the length of 50 minus x. So we just simplified the 100 minus 2x divided by 2. We simplify it, we get 50 minus x. And I'm going to write that in now over here. 50 minus x. 50 minus x. So now we have all 4 sides of our rectangle labeled. So finally, if we want to calculate the area, I'm going to have to write small here because I know I'm going to run out of space if I don't write small. So if we're going to calculate the area, we have length times width. So we want to do x multiplied by 50 minus x. Just multiply the 2 different sides together. Length times width. So x multiplied by 50 minus x. And then from here, all we have to do is simplify. So let's simplify by taking the x that's in front and distributing it to everything that's inside the parentheses. So we have x times 50 was 50x, and x times negative x will give us negative x squared. So once again, all we did here was take the x that's outside of the parentheses and multiply it to everything inside the parentheses. So x times 50 is 50x, and x times negative x is negative x squared. So once we've distributed it, we are pretty much done. We just need to switch the order so that it is in standard form. So you bring the negative x squared to the front, and then you have plus 50x in the back. Okay, let me box that. So that one would be our answer for there. Okay, are there any questions on this one? I'll pause the video to see if you guys have any questions. So I got a question that says, why do you have to change the order at the end? And so we're changing the order at the end so that it's in standard form. So standard form of a quadratic, let me check to see if it's in the notes actually. Right here. When I say here, you can't even see what I'm talking about. This box, box number 1. So according to box number 1, if you want to write a quadratic function in standard form, you want to write it in this form. So notice that f of x is equal to ax squared plus bx plus c. So the x squared term comes first. So you want to put that one in the front. That's why we switch the order. So the x squared comes first, and then the regular x, and then the regular number. So that's why we switched the order, because that's standard form. And the instructions wanted our answer in standard form. Yes, good question. Thank you for asking. Okay, let's go back to the skills practice. I noticed I made one tiny little typo on number 1. If you take a look at number 1, when we switched the order, we brought the negative 2x squared to the front. And I just noticed that I didn't write the x next to the 300. So please write your x next to the 300. That was my mistake. I just didn't write the x. So we just have to be more careful. I'm telling myself that I just need to be more careful. But the steps is the same. We just switch the order so that it's in standard form because you want the x squared piece first. Okay, let's do number 5 together. Number 5 is very similar to number 1. So I'm going to just zoom out just a tiny bit so we can still see number 1. It says, Kiana is making a rectangular vegetable garden alongside her home. She has 24 feet of fencing to enclose the garden around 3 open sides. So she wants 3-sided. Why would she make a garden with 3 sides? I don't know, maybe she's making it along the wall or something. Okay, so here's my 3-sided garden. Okay, and very similar to number 1, you want to label top and bottom as x. So that's how we get 2 of them labeled. Now we just need to label the 3rd side. So to label the 3rd side, we know that she has 24 feet of fencing. So 24 is our total amount of fencing. And then if we're going to use up x on the top, we're also going to use up x on the bottom. So in total, we've used up 2x. So minus 2x. Now 24 minus 2x should give us this leftover side. So it's the 3rd side. The 3rd side will be 24 minus 2x. So I'm going to go write that in. So it's very similar to what we did in this first problem, okay? We have x, and then we have 300 minus 2x because it's 300 feet of fencing. Now we have this problem over here where we have x on the top and bottom. We had 24 feet of fencing, so the 3rd side is 24 minus 2x. All right, are there any questions up till there? I'm going to pause the video and give you guys a chance.
Thank you.
Okay, so let's go on ahead and write out our area. So I'll just kind of draw a line here. I think I could fit it all here. So area of a rectangle is length times width. So once again, we just multiply the 2 sides together. X multiplied by 24 minus 2x. So multiply the length times the width. And then we're going to take the x in front and distribute it to everything inside the parentheses to help simplify it. When you do x times 24, that is 24x. When you do x times negative 2x, that's negative 2x squared. So once again, what we did here was we multiplied everything inside the parentheses by x because x was being multiplied to the parentheses. So x times 24 is 24x. X times negative 2x is negative 2x squared. And our last step is to put it in standard form. And when you put it in standard form, you want the x squared term to come first. So I'm just going to switch the order of it. So now it goes first, and then the other piece, the positive 24x, goes in the end. So it's negative 2x squared plus 24x. And now it's in standard form. Okay, pausing here again to see if you guys have questions. The next section says to use technology to determine the absolute maximum of each function. Describe what the x and y coordinates of this point represent in terms of the problem situation. Number 1, a builder is designing a rectangular parking lot. He has 400 feet of fencing to enclose a parking lot around 3 sides. Let x equal the width of the parking lot. Let a equals the area of the parking lot. the function a of x is equal to negative 2x squared plus 400x represents the area of the parking lot as a function of the width. So when it says use technology, that means we're going to use an online graphing calculator. So desmos.com. Let me write desmos.com over here. Just in case you forgot how to spell Desmos, that is Desmos, DESMOS.com. And what are we going to do in Desmos? We are going to put this equation into it. We're going to type this. Well, specifically, you only need to just type this part. So we're just going to type this part into Desmos. And then we want to find the absolute maximum of each function. Okay, so that's what we're going to do. By the way, some of you might be wondering what in the world is an absolute maximum. Some of you might be able to guess it, but let's refer to our notes first before we continue to figure out what an absolute maximum even is. So if we're going to go look at our notes, and if you look at box number 4 and 5, we have a graph and then the vocabulary word of absolute maximum is right over here. An absolute maximum is the highest or lowest value of the function. So if you look at the graph picture on number 4, the highest point would be the vertex. So this point would be the absolute maximum. Okay? There's also something called an axis of symmetry. Let's just go over the vocabulary words really quickly, I guess, since we're here already. There's also an axis of symmetry. It's the line that divides the figure into identical halves. You can see that drawn onto the graph right here. And you notice that it's where if you folded it, the graph will be folded into half. That is your axis of symmetry. Domain, we've talked about that a long time ago. Domain is the input or x values. Then there's also range, which is the output or y values. There's the vertex, which is the maximum high point or minimum low point of the graph. So as we can see, we kind of already highlighted the vertex. And then we have an x-intercept, which is the point where the graph crosses the x-axis. I guess I can highlight that in purple. This would be like this point and this point. And then we have a y-intercept, which is the point where the graph crosses the y-axis. So that would be over here on the graph in box number 4. And then finally, we have zeros, which are x values that make the function equation equal to 0, pretty much very similar to the x-intercept. So the zeros and x-intercept are pretty much the same thing. So once again, that is here and here. Okay. So we just kind of went over all the vocabulary, but specifically for the skills practice problems that we are working on right now, we just want to find the maximum. So let's go back to our skills practice. We're going to type this equation into desmos.com. So negative 2x squared plus 400x into desmos.com. So you go to Desmos, click on the graphing calculator, and I'm going to type negative 2x squared. That is not negative 2. Come on. Negative 2x squared plus 400x. Okay, and then you can see this straight line red graph. It should be a parabola, so it should be a upside down U shape. So that just means we can't see the whole graph yet. I'm going to zoom out until we can see the whole graph. Oh my goodness. This is a very high graph. Okay, there's the top of our graph. It took a long time of scrolling, but there it is. Oh my goodness. Okay, so I just want you to enter in your equation and then scroll out until you can see the top of your graph because we're looking for the maximum. So you want to look for the highest point. And once you find it, it's right there. Click on it and Desmos will let you know what the point is. So we clicked on it. Do you see the point that popped up? That's why Desmos is wonderful. You can just click on the point and it will show you. So it says 100, 20,000. So I'm going to go write that in. 100, 20,000. Oops, sorry. I don't know how that happened. 120,000. Okay. So we've determined the absolute maximum of this function. Now we need to describe what the x and y coordinates of this point represent in terms of the problem situation. Okay, so the x value is the 100. And they actually told us what x is. Let x equal the width of the parking lot. So the width of the parking lot is 100. Okay, so that's what the x represents. They told us what it represents. Now, as for the y value, they don't tell us what the y value is. But remember, in an equation, this a of x is equal to negative 2x squared plus 400x. That's our equation. Really, that tells us y is equal to negative 2x squared plus 400x. So the a and the y are the same thing. So if a of x represents the area of the parking lot, then y is the area of the parking lot. So 20,000 is the area of the parking lot. So once again, x, they told us what x was. I guess I can highlight it. X was the width of the parking lot, so that's this one. And then as for the y, it's what they tell us the equation represents. So if they said A is the area of the parking lot, then 20,000 is the area of the parking lot. I'm going to pause here and see if you guys have any questions. And let's do the next one. A baseball is thrown upwards from a height of 5 feet with an initial velocity of 42 feet per second. Let t equals the time in seconds after the baseball is thrown. Let h equal the height of the baseball, and the quadratic function h of t is equal to negative 16t squared plus 42t plus 5 represents the height of the baseball as a function of time. So remember, according to the instructions, we were going to look for the absolute maximum and then determine what the x and y coordinates represent. So let's type this equation into Desmos. Except I'm going to use the letter x instead of the letter t because Desmos prefers when we use the letter x, okay? So I'm going to write negative 16x squared plus 42x plus 5. So it was negative 16x squared plus 42x. I don't know why it's not letting me like press all the buttons. 42x plus 5. Okay, and obviously I'm far too zoomed out, so let's see, can I reset it? Yeah. Okay, so if you just press that home button, it resets your graph to be centered at 0, 0. And we can see this. Scroll, scroll, scroll. Let's look for the top. There's our top. Click on it, and it says 1.313, comma, 32.563. Okay, so I'm going to go write that down. 1.313, 32.563. Did I write that right? Yeah, 32.563. Okay. All right, so this one, our x value is our t value because I replaced x with t. So that says let t be the time in seconds. 1.313 seconds after the baseball is thrown. And then what about the 32.563? Well, the 32.563, that's our y value, and the y value is going to be the same as the h of t value. So let's see, does it tell us what h is? Let h equal the height of the baseball. Good, so this is going to be the height of the baseball. 32.563 is the height of the baseball. Okay. Okay. Any questions? I'm going to pause it so you guys can get a chance to ask. All right, number 5. Franco is building a rectangular roller skating rink at the community park. The materials available limit the perimeter of the skating rink to at most 180 feet. Let x equal the width of the skating rink. Let a equal the area of the skating rink. The function a of x is equal to negative x squared plus 90x represents the area of the skating rink as a function of the width. So I'm going to go ahead and type that into Desmos. Negative x squared plus 90x. Negative x squared plus 90x. Okay, so I'm just gonna keep zooming out and scrolling up until I find the maximum. Scrolling out. Oh, there it is. There's my other side. We're getting there. Okay, there it is. Click on the top and it will give you 45, 2025. And so that is our maximum. So we have to go ahead and write that down on our skills practice. 45, 2025. Okay, so then we need to figure out what does x and y represent. So once again, they told us that x is equal to the width of the skating rink. So that's what this number is going to be. 45 is the width of the skating rink. Okay, and what would the y value be? Well, the y value is the a value. So we have to figure out what is our a value. What does that represent? They say let a equal the area of the skating rink. So this must be the area. Okay, so now we have both of those labeled. Okay, so we have a half hour left, and let me pause the recording first to see if you guys have questions. All right, I've decided for the sake of time, this next section, part C, we're not going to do it. Okay, so you don't have to do the evens here for homework. I'm just going to emphasize that, I'm going to cross it out so that you know that this isn't part of the homework or part of the classwork. Okay, it's crossed out now for the sake of time. This is part of part C, so I'm just going to cross that out as well. And this one as well. So we just crossed out part C. You do not need to do part C as the homework or the classwork. Understood? Hopefully that's understood because I just crossed it out. So it's not that part. Let's do part D, okay? Part D. So it says, write a function that represents the vertical motion described in each problem situation. So this is going to correspond with box 7 in the notes. So I'm going to go ahead and look at box 7 in the notes once it loads. Okay, there it is. So we have this equation in box 7. It's the vertical motion model. H of t, where h is the height. H of t is equal to negative 16t squared plus v naught. 0 is a naught, okay? So v naught times t plus h naught. Okay, so what does this v mean? This v is the initial velocity or starting speed. Okay, and then what does h of 0 mean, or h naught mean? H naught is the initial height or starting height. Okay, so take a look at this equation. And hopefully that was enough time. Let's go back to the skills practice. So we're going to write a function that represents that vertical motion. I'm going to write the equation up top. Okay, here's our equation. So for number 1, it says a catapult hurls a watermelon from a height of 36 feet. This is the initial height. If you hurl it from that height, this is your initial height. This is your h naught. At an initial velocity of 82 feet per second. This is your v naught. It's your initial velocity, so that's your v naught. So when you put it together, I think you guys are going to like how straightforward this one is. H of t is equal to, we have our negative 16t squared plus v naught times t. So the initial velocity is 82. So it's plus 82t. And then you finally have plus h naught. So that's plus your initial height. Our initial height was 36. So it's negative 16t squared plus 82t plus 36. Okay, I'm going to pause here, see if you guys have any questions. Next example, a catapult hurls a pineapple from a height of 49 feet. So this is your h naught. At an initial velocity of 110 feet per second. So this is your v naught. So putting it together, h of t is equal to negative 16t squared plus. All right, now this is the v naught times t. So our v naught was 110. So it's 110 times t. And then finally, as the last part of our equation is you're going to add the initial heights, so the h naught. So what was our initial height? 49. So plus 49. All right. So I think this one is the most straightforward section, which I enjoy, and I'm sure you guys will as well. So let's do number 5 together. A soccer ball is thrown from a height of 25 feet. So it's thrown from that height. This is your initial height. So that's your h naught. At an initial velocity of 46 feet per second. So initial velocity, that would be your v naught, so the v0. Plugging it into our equation, we have negative 16t squared plus our initial velocity piece. So that would be 46 multiplied to t. And then finally, plus our h naught piece, our initial height. So our initial height was 25. So then putting it all together, here it is. H of t is equal to negative 16t squared plus 46t plus 25. The 46 was your initial velocity, the 25 was your initial height. Okay. So I promised at this point that I would go to show number 1 again, so I'm going to pause the recording so I can do that. Last section. Identify the vertex and the equation of the axis of symmetry for each vertical motion model. So it's 1, 3, and 5 is what we're going to do together. So once again, we're going to go to desmos.com. We're going to type in this equation. It's kind of separated, but we'll type that in. So we have negative 16. Instead of the t, I'm going to use an x. Actually, let me type the 6 first. Okay, negative 16x squared plus 64x plus 40. I don't know why it's not letting me press all the numbers, but okay. Negative 16x squared plus 64x plus 40. And of course, I don't see it here because I'm scrolled all the way up to the 2000s. So you see on the right side where there's a home button? Like underneath the plus and minus, there's a home. So it's settings plus minus home. I'm going to press the home. So it centers me back here and I can see my graph, which is great. Now I'm going to scroll up until I see the vertex because we're looking for the vertex. There's our vertex, 2, 104. Oh, is it? Wait, did I just type the equation wrong? Oh, yeah. Oh, I was looking at like the second problem. I mean, number 3. My bad. Sorry. Let me delete this and type the proper equation. Okay, number 1's equation was negative 16 t squared plus 80t plus 24. Thank you to the student who was like telling me I typed it wrong. Okay, so I just looked at the wrong equation when I typed it in. My bad. So negative 16x squared plus 80x plus 24. Okay, now let me scroll to the top of this. There you go. So it's 2.5, comma 124. Okay? 2.5, comma 124 is our maximum. It's our vertex. It's the bendy part of the parabola. So it's 2.5, comma 124. 2.5, 124. So this is our vertex. And then the axis of symmetry, we're going to want to write the equation for it, right? Write the equation of the axis of symmetry. So it's super simple. It's literally the x value, 2.5. So since it's the x value, you write x equals 2.5. So that's your axis of symmetry. Okay? So number 3 is this very similar thing. I think I typed in that equation the first time, so now I have to type it in again. So let me go back and type in the equation for number 3 now. Back onto Desmos. So negative 16t squared plus 64t plus 40. So back onto Desmos, we have negative 16t squared plus 64t plus 40. Okay, so here's this graph. I'm going to center us at the home again so I can actually see it. Then you're just going to scroll up until you find your vertex. So scroll up. There's my vertex. It was 2, 104. So I'm going to go write that down. 2, 104. Vertex 2, 104. And then for our axis of symmetry, super simple. Super simple. It's literally the x value. X equals, our x value was 2. So our axis of symmetry is the vertical line at x equals 2. Okay, pausing here to see if you have any questions. Last example. We're going to go ahead and type this one into Desmos. Hopefully I type it correctly. Okay, so instead of 64x, it should be 48. I don't know if it's my iPad that's breaking or like what. Do I just have soft fingers or something? Whatever. Okay, here's our last equation. Negative 16t squared plus 48t plus 20. Let's find the vertex of this graph. 1.5, 56. Okay, now to write that down. 1.5, comma, 56. Cool, so this is our vertex. And then I'll write the axis of symmetry on the right side instead of the bottom because it's where I have space. So once again, the axis of symmetry, it is simply the x value. So you have to say x equals 1.5. And then that would be your axis of symmetry. It's just the vertical line that divides your graph in half. X equals 1.5. It's just the x value of the vertex. Okay, any questions? Please let me know in the next 10 seconds. I'm pausing the video to give you guys a chance.